Hello everyone, I hope you are going great. In this moment, I want to share with you and I want you to know a bit more about understanding algorithmic complexity. If you are an IT engineer or a junior IT engineer, this video is great for you. Okay, so what is algorithm complexity? Algorithm complexity is a measure of the amount of resources required to run an algorithm. It addresses how the amount of time and space used by an algorithm grows relative to the input size. Understanding algorithmic complexity helps developers make informed decisions about which algorithm to use based on their efficiency and optionality. It's crucial for optimizing performance and ensuring scalability in computer program. So now we're going deep into time complexity. What is time complexity? Time complexity refers to the amount of time an algorithm takes to complete as a function of the length of the input. It typically is expressed using big O notation. We classify algorithmic according to how their runtime or space requirement grow as the input size grows. Understanding time complexity is crucial for evaluating the efficiency and scalability of an algorithm, which help in choosing the right algorithm for the right problem. The common time complexity is constant time when an algorithm is executed independently of the size of the input data set, like accessing of a specific element in an array. Logarithmic time. Logarithmic time is like the time taken grow at a slower rate where the input size grow. With problem like size in half each time, such as binary search. Another common time complexity is linear time. It's like when the execution time increases linearly with the input size. A common example is iterating through an array of elements. Quadratic time complexity occurs when the execution time is proportional to the square of the input size. This is commonly seen in algorithms that involve next iteration over the dataset, such as bubble sort. Exponential time algorithms have an execution time that double with each addition to the input size. These algorithms are often impractical for large datasets, such as recursive solution to the Fibonacci sequence. Now, what is space complexity? It's a computational metric for measuring the amount of memory that an algorithm requires to execute. It includes both the space needed to the input value and additional space used for variable, data structure, and any overhead created by the algorithm during its execution. Understanding space complexity is crucial for optimizing algorithms, especially in environments with limited memory resources. Space complexity is usually expressed in terms of big O notation, which classify the memory usage in relation to the size of the input data. This allows developers to predict how an algorithm memory requirement grow as the input size increases. In order of space complexity, we have auxiliary space complexity. The auxiliary space is the extra space or temporary space used by an algorithm excluding the input data. This is crucial for determining how efficiently an algorithm runs regarding additional memory usage required aside from the input data. And the total space refers to the overall memory required by an algorithm, including both the space occupied by the input and any auxiliary space used during its execution. This is important for understanding the complete resource consumption of an algorithm. In-place algorithm algorithm that transform data using a small constant amount of extra space. The primary goal of in-place algorithm is to minimize memory usage while performing the necessary computation. Example of in-place algorithm is bubble sort, quick sort, and insertion sort. Importance of algorithmic complexity. First, perform measurement. Algorithmic complexity provides a framework for measuring the performance of algorithm in terms of time and space. Understanding this complexity helps in evaluating how algorithm will function under various input size and conditions. Scalability insight too. By analyzing algorithmic complexity, developers can judge how well an algorithm will scale as the amount of data increases. This insight is crucial for applications that handle large data sets or require high performance. 3. Optimization credence. Understanding the complexity allows developers to optimize the algorithm, choosing the most efficient solution for specific problem. This can lead to significant performance improvement, reducing resource usage and execution time. Fourth, comparison of algorithm. Algorithmic complexity serves as a tool for comparing different algorithms and their efficiencies, helping developers make informed choice about which algorithm to use for a specific task based on performance metrics. Example of different algorithmic complexity. Linear search. First, a simple algorithm that checks each element in a list one at a time until the desired element is found or the list ends. It has a time complexity of odd n, where n is the number of elements in the list. 2. Binary search. An efficient algorithm that finds the position of a target value within a sort array. It reduces the problem size by half with each step, yielding a time complexity of big O log n. 3. Bubble sort. A straightforward sorting algorithm that repeatedly steps through the list, compare adjacent elements, and swap them if they are in the wrong order. It has a time complexity of big O n exponential 2. Fourth, quick sort. A highly efficient sorting algorithm that follows the divide and conquer paradigm. It selects a pivot element and partitions the other element into two sub-arrays according to whether they are less than or greater than the pivot. It has an average time complexity of big O n multiplied by log n. So, what do you need to understand during this video? You need to understand that when you want to build a project, you need to reflect on algorithm complexity. Understanding algorithm complexity is crucial for optimizing performance and making informed decisions when choosing algorithm for software development. Take time to analyze and assess the complexity of algorithm you encounter or implement. So you need to experiment with different algorithms. Practice by implementing various algorithms and measuring their performance. Use different data sets to better understand their complexity and improve your coding skills. 3. Join community. Engage with the programming community by sharing your findings and experience with algorithm complexity. participate in forums, discussion group, or local meetups. Fourth, stay updated. Algorithm development is an ever-evolving field. Stay informed about new research and events in algorithm design and complexity analysis. I hope this video helped you to know a bit more about complexity, space, and time in algorithm. Thank you. Thank you for watching this video. Follow for more exciting video like this or more like this.